Now let's talk about climate. Climate refers to a long-term weather pattern. This is very different from weather by itself. Weather is day to day or short term. Climate is long term. It's usually at an average of about 30 years. So the climate of a region, you're looking at an average of a long time period. While weather is short, day to day, weather can change each day. A climate would not be changing each day. Climatology is just the study of the Earth's climate, the study of the long-term changes or long-term weather patterns. Climate normals. This refers to the basic standard values for a location, or just in plain words, the average value over a long period. What is normal? Okay, what is the normal climate? That's all this is saying. Okay, here are some factors affecting different climates. Topography. So this is the shape, the elevation, the features of the surface. So topography is referring to, are you going to have high points or low points? Are you going to have very tall mountains or very low valleys? Okay, these are the ups and downs in your surface of the earth. In 8th grade earth science, you should have learned about topography, the different ups and downs of the earth. Altitude is referring to the height of an object above sea level. This falls under topography, dealing with how high a mountain may be or how low something would be. So does it have a high altitude or low altitude? Okay, so this is referring to areas of higher elevation, okay, are generally going to be higher up. It's generally going to be cooler. So this is going to impact the climate of a certain area. And these are the temperature factors, Another temperature factor dealing with topography would be location near a body of water. So if it's near water versus inland, it's going to be different. If it's near water, generally it's going to be cooler in the summer and warmer in the winter. So just imagine that if you're near the beach, probably if you think about some places like the Mediterranean, like Greece, it's going to have warmer winters and cooler summers. But if you're inland, there's a greater chance of you having colder winters, and so it's going to be very, the inland climates are going to be less moderate and more of an up and down, more of an opposite or an extreme high to low in the temperatures. So your inland climates, okay, would have a larger range. If we look at this climograph, basically this is going to be showing temperature at the month. And so basically what we're seeing here is city A in the winter months, very cold, in the summer months, very hot or hotter. So city A would be inland. City B is more mild or moderate, so most likely that's going to be near the water, like a Mediterranean location. Another factor that impacts climate is the ocean currents. This will be also impacting temperature. So if it's bringing water from the equator, these places are going to be warmer. If the ocean current is moving cold water, okay, past this area, it would be colder. Okay, but the ocean currents, the cold water, does get warmed up as it's brought back to the equator and then moved back out. Okay, another factor is latitude. Latitude is referring to the location on the Earth, whether it's at the equator or at the poles. Now, something you need to know is that the equator, the center line of the Earth, is 0 degrees. That's the equator. Now the North and South Pole, that is at 90 degrees. So if we're looking at latitude, the higher we go from zero, we're moving to the poles, okay, it's going to get colder. So further away from zero, it's getting colder. If it's closer to zero, it's going to be warmer. And so here we have basically, here's the graph being plotted. And so at 0 degrees, it's high temperature. And as you move out to 90 degrees, it's going to be lower temperatures. That's how you would be plotting the graph. Above the zero, high temperature. As you get closer to 90 degrees, the temperature drops. And therefore that line, that graph, the line is dropping. Closer you get to 90 degrees, colder, colder, colder. The line is getting lower because lower temperature. Higher, closer to zero, higher temperature. So the line is high. Closer to 90 degrees, the line is low, lower temperature. Okay, yearly temperature range. Remember what a range refers to? A more of a spread out, high to low. It's not specific. It's more of a in the ballpark or in a vicinity. So the yearly temperature range. Okay. Basically, if we look at the right hand graph, basically it's showing in the months J starting with January, then we have February, March, April, and it ends with October, November, December. So basically as temperature increases, okay, you're going to see a larger range at places that are, you're going to see a higher range. Places that are high latitude, you're going to see that it's very cold in the winter, but it can get a lot warmer in the summer. Now, mid-latitude, it's more of an average. There's still that little peak. It's not as much of a difference, but you still have, but it's going to be a little more milder. But then the low latitude, remember, low latitude is closer to the equator. 0 degrees is a low latitude number. High latitude is 90 degrees. So the low latitude number, it has a high temperature all year round. So basically, if you're at the equator, you don't have a big temperature range. You don't have cold in the winter, hot in the summer. You basically have hot all year round. So let's look at the graph at the bottom. Okay, 0 degrees. Okay, is there a big change? No, we said it's pretty much hot all year round. But as we move to 90 degrees, okay, there is a larger range going from cold in the winter, hot in the summer, a larger range. So remember, this chart is not saying it's going to be increasing temperature. No, it's increasing the range between cold in the winter and hot in the summer. So 90 degrees, more of a difference in the months, while the equator is pretty much going to be hot all year round. Now look at the line in this example, and then look at the line here. Now look at the line here in this graph. This is the graph we talked about on the previous slide, but basically the graph is going, the line is going from high to low. This is talking about temperature change. I go back to temperature range, it's a different line in that graph. Now, average yearly temperature, when temperature is compared to altitude, this is now different. I'm not talking about latitude now, I'm talking about altitude. So I'm not talking about the lines from the poles to the equator. I'm not talking about that now. Now I'm talking about a mountain, maybe low latitude at the base of the mountain, top of the mountain, high altitude. So basically what this is saying is that the average yearly temperature is higher at the base of the mountain. So temperature is higher at the base. So you can follow the altitude line. It's increasing as it's moving to the right, or the altitude arrow is pointing to the right, so it's saying altitude is will be increasing. So if we look at the arrow pointing up, average temperature is increasing. So the line that's created says or shows, the line that's created shows that high average temperature at the low altitude, at the base of the mountain, okay, is going to be warmer. The base of the mountain is going to be warmer. But as I increase altitude, the line slowly goes down, showing as I increase altitude, it gets colder and colder and colder. So this is more common sense. At the bottom of the mountain, it's going to be warmer. At the base, at the top of the mountain, increasing altitude, it will be colder. Okay, so topography, we said the highs and lows. Here's the latitude lines. These are the latitude lines you need to know and the zones. So the latitude lines are on the left bottom circle. We have the Arctic Circle, Tropic of Cancer, Equator, Tropic of Capricorn, and Antarctic Circle. So you need to know these names and the latitude degrees. And then the space between those, okay, are the zones. So you can see it's not written here, but the pole, the very top, would be 90 degrees. So between 90 degrees and the Antarctic Circle, so between the North Pole and the Antarctic Circle, is the polar zone. So between the Antarctic Circle and the Tropic of Cancer would be the temperate zone. And these are the very general zones. We'll get into more detail next week. Now, between the Tropic of Cancer and the equator is the tropic zone. And then you have it repeated between the equator and the Tropic of Capricorn, another tropic zone. And then between the Tropic of Capricorn and the Antarctic Circle, we have the temperate zone. Now, between the Antarctic Circle and the South Pole, you have the polar zone again. You will need to know the latitude lines and the zones, and we'll have a little practice with these. So I would get in the habit of maybe writing these down, practice them if you don't already know them. Okay, the second focus is not just on temperature, but rainfall. So primarily latitude, those latitude lines, the closer you are to the equator, most likely you're going to have. Now, the rainfall factors are impacted by the latitude lines, and if you look at the picture there, you can actually see that it's not just at the equator, but basically at the 60 degree, okay? The 60 degree latitude line, the 0 degree latitude line, and the 60 degree latitude line, you have a lot of moisture. Now, at the 60 degree latitude lines, primarily it's going to be colder, so that moisture may be in the form of snow. At the 0 degree, okay, it's too warm, so it's going to be rain. Now, it's generally going to be dry at the 30 degree, okay, latitude lines and at the poles, okay, generally more dry in those areas. Okay, not a lot of rain. And the reason for that is evaporation. So if you look at the outside of the little oval, okay, so basically you have these arrows. So basically at the equator where there's a lot of moisture, basically what's going to happen is it's going to evaporate, it's going to come down. Now mountains, this is something you learned in 8th grade about orographic precipitation or orographic lifting. So as moisture rises up, it then gets cold, higher altitude, it starts to condensate, forming clouds. So usually as the warmer moisture rides up the mountain, it's going to rain on that side. You have the rain shadow, so cooler air, okay, less moisture. And then we have calendar seasons. Don't forget the Earth. In winter, the days are shorter, so it becomes cooler, okay, for longer periods. And this is impacted by the Earth's tilt. Basically, you should have learned about the summer solstice, okay, longest day of sunlight, and this is primarily in June, end of June, like the 21st or 22nd. And then you have the winter solstice, which is on December 21st, shortest day of sunlight. And this is basically how the Earth is tilted, and the sun is focusing more on the southern hemisphere. While the summer solstice, the Earth is tilted towards the sun and is focused on the northern hemisphere.